Okay, Chargers, we're going to talk about a couple of things. We're graphing and using f of x equals ax squared form. We're going to talk about what happens. We're going to do a lot of things. I'm kind of blending a lot of different things into this video that I think you're going to need for several assignments. So the question is, what happens when we have ax squared, right? And then what happens when we have negative ax squared? When the a is less than 0. So anything bigger than 0 produces parabolas that go right and up and left and up. The outputs go up, 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 and so they look like that. And then let's say that you had f of x equals negative x squared. Any negative number, right, anything less than 0, points in the opposite direction. We're also going to talk about what happens when a is larger than 1 or less than 1. We're going to talk about that in the first one. So we're going to go from there. I'll just get going. You'll notice that I have some vocabulary. Also in this video, I'm going to try to teach you how to describe the differences in what we see. So what I'm going to do is I'm going to create a coordinate plane here, a pretty simple one, and I'm not going to use a lot of inputs for x, so that's going to be rather short down there. All right, and we're going to graph both of these. And what I'm going to try to teach you here is what happens, or how is the graph affected when the a is different. They're both bigger than 0, right? The blue is 1x squared, even though it's not written, and then 2x squared. And then that's a vertical stretch. I'm not really going to need to talk about vertical shrink down here. I think what I'll do is I'll talk about vertical shrink here. I'll do 3 on this one. And so I guess I'll do a third, and let's just go h of x is 1/2 x squared. I just want to show you the stretch and the shrink, and we'll do it all in one. Okay, so let's go ahead and start graphing these. And the first thing to be aware of is that you can do this in Desmos. But I'm going to do them by hand here so you can see how organically these points are derived. We're still inputting and outputting. We're still inputting and outputting here. And so let me go ahead and do that. I also want to tell you that I'm just really going to focus on positive inputs, but you should know that when it's x squared, any of the negative inputs give you a positive output for y. So it's kind of a mirror image deal. So we're going to go ahead and graph the base. We're basing everything off of this. And so we're going to use the inputs of 0, 1, and 2. We'll use the inputs of 0, 1, and 2. And we'll use the inputs of 0, 1, and 2. Makes everything really pretty easy to figure out. So if I put 0 into x squared, I get 0. I put 1 in, I get 1, and 2, I get 4. Okay? So let's go ahead and graph that real quick. Now this is only going to give you the positive side, 0, 0, 1, 1, and 2, 4. All right? Also understand that when we put the negative inputs, negative 1 and negative 2, we get the same outputs. So I'm going to draw in the other part of that parabola. Okay? And so I'm going to try to draw this so that it looks right. See, it's already goofy. That's okay. We're going to get the main idea. Then we're going to graph 2x squared. So it's still 0, 0. Look at that. They share a common vertex. It's 1, 2, and 2, 8. So you'll notice right here that we go from 1 to 2 and from 4 to 8. So the output is doubled because you have that 2 multiplying the x squared. And that produces what we call a vertical stretch, vertically. Okay, so I graphed 0, 0, 1, and 2. There's the stretch right there. You see it? All right, and then 2, 8. and then we have the negative side as well. So there you go. There's the parabola. And that's called a vertical stretch. Okay? Now, vertical shrink, right? That's going to come from our purple equation, vertical shrink, because everything is, all the outputs are half of what they were in the blue. Okay? And that's called a vertical shrink. So we're going to grab 0, 0. Again, same vertex, but 1 and 1/2. There's the shrink. You see the shrink right there? And then we have dots at 2, 2. 2, 2. All right. So even though it's a little counterintuitive, you have a vertical stretch on g of x equals 2x squared, but it makes the parabola skinnier. It's kind of weird. And then oppositely, the vertical shrink makes it a fatter or a wider parabola. So I just wanted you guys to understand that. When we compare these, they have the same vertex at 0, 0. They have the same axis of symmetry, x equals 0. So that's how we would describe these three. We would describe based off of f of x equals x squared. The g of x is a stretch, and the h of x is a shrink. And so hopefully you can see it's a vertically shrinking per given input. All right, now we're going to talk about what happens when we have, we've got two parabolas here, one that is positive and one that is negative. And you know what I need to do? I definitely need to extend this line a little further because we're going to be going below that as well. So what happens when the a is less than 0? So in other words, it's a negative number. All right, I'm going to go ahead and quickly make an input-output table for the x squared. And here's your x, here's your y, 0, 1, 2, 0, 1, and 4. We did that before. I'm not going to spend a ton of time going over that. There's 1, 1, there's -1, -1, and then 2, 4, and then we have -2, +4. There's the parabola. I think I'm just going to leave the dots without drawing in the parabola, and then I'll fill it in the end. When we do this one, all right, that -1 or negative, right, x, y, we have 0, 1, and 2. The outputs are going to be virtually the same except negative, right? -4. So when we go to graph this, we have the same common vertex. We have, it's almost like it's a reflection across the x-axis. And so we have dots at 1, -1, and -1, -1. And then we have dots at 2, down at 4, 2, down at 4. And so again, they're really just a reflection of one another, aren't they? But that's what happens. It just flips it upside down when it's negative. It goes down, right? Because your outputs become negative, so they go below the x. They have the same vertex, right? 0, 0 is the vertex. The axis of symmetry is x equals 0. But the effect of that a being a negative number or less than 0 just flips it below the x-axis as compared to x squared.